data collecting and processing for the Earth satellites. It has also borrowed some from other nations. But for moon exploration, we have built a new software system to accomplish our goals.
Data from the moon can only be received for about 10 hours a day. That's because there are only several hours when the Earth and the moon are in proper alignment to retrieve data. Chang'e-2 uses these payloads to achieve their scientific goals. During the period of Chang'e-2 in moon orbit, the ground research and application system here will keep recording and retrieving data from the deep reaches of space. The work here will decide the final results of Chang'e's mission. The journey of Chang'e-2 lasts for about half a year, but for these scientists, studying the data they send back from the moon could last much longer. Han Bin, CCTV, Beijing.
Now, to talk about the cooperation between China and EU, let's bring in Karl Bergquist, the administrator of the International Relations Department at the European Space Agency in Paris. So, Karl, could you please brief us on the cooperation between EU and China this time, especially in the area of tracking and monitoring of the spacecraft? Karl?
Yes, we have a cooperation with China since we started actually with the Chang'e-1. Where China asked to, as a complement to its own station, also use some of our station. This is, of course, something which is very important, in particular in this phase, the first phases of the when the satellite is being launched and when it goes all the way up to the moon. And for Chang'e-2, there will be the same thing. And ESA we will use our station that we have in French Guiana, which will be triggered in about 6 to 7 hours from now, in order to follow the passage of Chang'e-2.
And also, let's talk about the cooperation in the fields of astronomy. What do you think European Space Agency can do with China in the field of astronomical research?
We have a cooperation since we had a big cooperation program called Double Star a few years ago, and since then this was a highly successful cooperation, not only scientifically but also the two organizations learned to work together. And ever since then we meet on a regular basis each year in order to see, these are European programs, these are Chinese programs, what can we do together? Because the idea is not to do it's really to find complementary things together. Space is very expensive and difficult, and therefore we should not duplicate our efforts, but try to see to what extent can we cooperate together in order to achieve more and better science.
Okay, thank you, Karl. That's Karl reporting from the ESA. And you are welcome to our special broadcast. That's our special broadcast, Journey to the Moon. We have seen the liftoff of Chang'e-2, China's second lunar orbiter. It's a successful liftoff, and now Chang'e-2 is on its way to the moon. And in the studio, we have several panelists to discuss this mission. Mr. Peng Jing from the China Academy of Space Technology from CASC, and also John Lewis from the Lunar and Planetary Laboratory of the University of Arizona in the U.S., and also Mr. Roger Burnett, Executive Director of the International Space Science Institute of ESA. Well, already Chang'e-2 is on its way to the moon. What we will encounter on its way to the moon?
At first, after the separation from the third stage, the Chang'e-2 will have, I think, 12 hours journey before it arrives at the moon. And during this long journey, there are a lot of things shall be done by Chang'e-2. At first, I think maybe 20 minutes after separation, the Chang'e-2 will enter in the sunshine zone, because now the sunshine is blocked by the Earth, so the solar panel of Chang'e-2 cannot collect any solar power. But after 20 minutes, it's possible for Chang'e-2 to deploy its solar panel to collect the solar energy. And then maybe I think from 4 hours to 17 hours after liftoff, there will be 4 times experiment for 2 small cameras. One is the ultraviolet sensors. It's something like a camera which will be used to take photos of the moon to acquire attitude information about of the orbit. And another test will be conducted by the monitoring camera. With this camera, Tianwei has introduced that the camera will take photos about the deployment of solar panel, and even when the time is appropriate, the camera will be look at the Earth and take photos of the Earth, and the data.
So on its way to the moon, the
Yes.
monitor camera will take pictures of itself and also the moon.
Also the Earth, yes. And because when it takes photos of the Earth, the orbiter cannot be controlled by ground station on China. So the photos, the image will be stored on board the memory of the orbiter. But tomorrow, when the orbiter fly into the telemetry, into the span of China own ground station, we will receive those images, and maybe we can see these pictures in 1 or 2 days.
Mm-hmm. It seems that we have several days to wait until it reaches the moon, and it is basically vacuum between the Earth and moon. Is there any test for the orbiter?
There is one critical event which we hope doesn't happen, which is when the spacecraft must pass through the radiation belts on the way out, and we will keep our fingers crossed that it's well enough designed and prepared.
Explain to us, what is the radiation belt?
The radiation belts are charged particles originating from the sun, which are trapped in Earth's magnetic field and form a band around the Earth close to the equator, actually the magnetic equator. Mm-hmm. And these charged particles exist in high concentrations locally and in fairly high energies, so they can be damaging. But everyone knows about these radiation belts, and spacecraft are designed to pass through them safely. Yeah, the spacecraft Chang'e will not spend much time
in that belt,
in the heart of the belt. It's traveling outward through that belt. The most intense radiation will probably last 15 minutes to half an hour, something like that, and then it will be in a much more benign and stable environment for the rest of the trip out there, unless the sun surprises us.
Unless the sun have some particular events that
Yes.
that send radiation from the sun.
Right.
But that's an unlikely event, or we don't know.
Well, the sun does it all the time, but again, spacecraft are designed with this in mind. But sometimes the sun is unpredictable.
And let's also talk about the instrumentations on Chang'e-2. What are those essential instruments that we must use during this journey when it's approaching the moon?
I think the payload, in the 5 type of payloads, there are, I think, high energy particle detector and ion detector of solar wind will be used during its trip to the moon. We want to study the space environment between the Earth and the moon. Those 2 type of instruments will work during its journey to the moon and collect some scientific data of the space environment and returning those data back to Earth to help us to understand the activities of solar wind or such.
Why do we need those data, like the X-ray spectrometer, the laser altimeter? Why do we need the data of this? Why we just go there? We have already the map of the moon.
I think the scientific data collected by Chang'e-1 is not so precise because its nominal orbiter is 200 kilometers. But for Chang'e-2, we have lower orbit, so the accuracy of those data might be higher. And after scientific exploration conducted by Chang'e-1, we know something. We know a lot about the mineral or element composition of the lunar surface, so we can change the design of our gamma and X-ray payloads to make it work more better than the instruments used by Chang'e-1. It means we have conducted gradual technical improvement one by one.
Do we have to know in that detail of the composition of the moon? What is the purpose of knowing so much about the Earth, about the radiation on the moon? What is it so important?
Well, first of all, there's the fundamental scientific issue of what the composition of the lunar crust is and how it varies regionally. The question is incompletely answered because it's largely based upon remote sensing right now, and will still be after Chang'e. But Chang'e will get down to low altitudes, and therefore will have better spatial resolution in its chemical analyses of the surface. This is somewhat offset by the fact that when it's very low, it doesn't have much time to observe. So it's going to be averaging over a strip on the surface of the moon. That's okay. We understand what that means.
It's a narrow strip of the area on the surface of the moon, but it's where the Chang'e missions will concentrate on, right?
Right. The gamma ray spectrometer, for example, is not a directional instrument. It will receive radiation from any direction, and when it's receiving, for example, radiation from uranium decay in the crust of the moon, it will see preferentially the part of the surface of the moon that's closest to it. So,
okay, let's talk about the payloads of the Chang'e-2 in detail. The payload actually will bring about the clearer images of the moon, as we've just explained, and also carry out some deeper scientific experiments. Li Chunlai, the chief designer of the satellite's ground research and application system, made such remarks during an interview with our reporter, and let's take a look at what he has to say.
Tell us the unique role of the ground research and application system in the whole project.
The ground research and application system functions are important throughout the entire Chang'e project. This is because it starts at the earliest with setting scientific goals and concludes at the latest as it gets the final result. It determines whether the data can be acquired, what apparatuses can be used, and how to allocate the payload. When it is in operation, we need to make sure this apparatus works and monitor the working state of each payload every day. We need to process the data sent back and decode the data to fulfill scientific goals.
What are the major scientific tasks of Chang'e-2?
We didn't change too much on the payloads, so the scientific objectives are kind of a continuation and deepening of Chang'e-1's. The scientific objectives include acquiring 3D images of the lunar surface, analyzing the amount and distribution of elements on the lunar surface, investigating characteristics of lunar material, and exploring the relationship between the Earth and the Moon. For example, the spatial resolution of the Chang'e-1 is 120 meters, while Chang'e-2 reaches 10 meters at a height of 100 kilometers. The Chang'e-2 can reach as close as 1 to 1.5 meters in an orbit 15 kilometers away.
Tell us the payloads to carry out the scientific experiments, and what are they different from Chang'e?